Hey everyone, in this video we are going to create a Python web scraping workflow where you build a simple yet customizable script that collects topic mentioned from the web, store them safely without duplicates in a continuous manner, scheduled manner, perhaps you run it weekly, and generate the final found data in a clean and useful data structure in database, but also we visualize them in a web HTML format, in a dashboard kind of format. As you see here, for example, I'm looking at a set of news items related to AI regulation policies, related to privacy policy, let's say, and I have a set of um, sources in web that I'm interested to look for. We customize. I'm going to show you how to customize and get them here. My source is RSS feeds, news feeds, for example. I'm looking at certain keywords and I want to run this weekly or in a scheduled manner, and I don't want to have duplication. That's very important for me, right? So, because every time you look at the news, and some of the news may be recirculated, or perhaps it's the same item, so you don't want to have duplication there. And here I have also visualization in terms of in the simple dashboard, it shows me the number of times that these news items, these certain topics are mentioned over the time. So I show you a snapshot here, but let's see what is happening in the code itself. So here the main libraries that we're using is actually feed parser is the main one, which we use to essentially have a stable web collection from the RSS feeds. I'm going to show you how we use that. So that's one of the key ones. Perhaps that's a new item you need to install in your environment. The database that we have at the end. So this is the final. Let me show you the output at the end. Going to be the dashboard HTML file that will show you. Perhaps it contains a couple of pictures. So this is the timeline of the mentions. It gives you a sense of the frequency of the news that you're looking over time, and then I separate the new items in a separate CSV files. In this case, this is also a use case for using SQLite, so I'm using that, and the output would be a database, and the database at the end will look like something like this. So we have different rows of the items that we found, the source of them, the title, so on and so forth, and also you could run it. This is the table for how many times we ran this schedule and what are the sources. So these are the source information that I'm looking for. Again, this is the example of using RSS feeds. We have the name and the feed URL, so on and so forth. So this is the item that actually a script itself show you, but the customizable information is in config.json file. So the input is just two items that I'm providing to you. Is this Python script and this config.json file. So the config.json file first shows you, okay, what's the topic that actually we're looking for. That's the topic. Then we break down this topic to a certain keywords related to different dimension in that topic. So first dimension is AI, then regulation, and inside the regulation, perhaps a specific type of policies you're looking for, and combination is the one that we're looking for essentially. So I'm going to show you what's the keyword match logic I'm using. You could make it more complex or less so depending on your need. That's the feed, and then we have few items in terms of how many items you want to grab for each feed in your uh, um, in your dashboard, and also whether you want to have the meta information, metadata from each um, feed as well or not. So let's look at the script itself. As I said, feed parser is just to get the RSS feed information. We use this one just for storage of the final information. Again, you can have it just in a CSV file if that's what you need. But as a research workflow, a web scraping workflow where we don't want to have duplication as well, I think putting it in the database makes sense. And then request and beautiful soup is the one that we use for scraping for the metadata. And hashing again, the hashlib is what we use for one of the items we use to make sure the duplication won't happening to standardize the title and the URL, and the rest is some housekeeping, smaller, the usual libraries that you perhaps use. Again, so the input is just a JSON file and this Python script. The output going to be this information. The final database, the new items from the new sources that you find each time separately, and this is for the dashboard that I show you, and that is metadata for each time you ran this script. So let's look at the main body. Let's start to actually run this and put this aside. And then as we go, I'm gonna step by step go over them. There are not too many steps, and I'm gonna go over just to show you a couple of demos and what you can customize. So this is grabbing just the information from the config JSON, and when we ran this, I just want to show you that feed information we had in that JSON file. We had again here 5 sources and their feed URL is kind of standardized enough, and that's a common use case using RSS feeds for especially for news search. I have some helpers again for housekeeping stuff, for making sure the dates are as it expected. Usually you have some dates for when this RSS feed is published, updated, created. I want to make sure they are in the format that I want, and so we don't get any error for them, and making sure we have a standard time zone for them because you get it from different sources. And again, similar some housekeeping. As you go through cleaning the data, you find some usual functions that you, instead of doing it every time, perhaps it makes sense to have a function for them. So let's run them here. This is the portion I want to show you, just 3 functions that I use to normalize the title, normalize or standardize the URL, and then create a unique identifier uh, um, for each of the URL with their title. Okay, so the reason we use them is this is one example, one quick demo to show you. For example, when you look at these 2 URL, you know that there are different use cases. This is one example. When when you actually look at them, they are the same URL. You don't want to read them as 2 different unique URL and double count and duplicate the number of news from this, right? That you may find for some reason if you have them in your source. So this is something to make sure when you run this function. So normalize title, just make sure there are certain um, types of string that are used that we can get rid of them and standardize them, and then we use this normalized title inside the making identifier, as well as standardizing a URL. And for URL, this is one example that I show you that, for example, sometimes we are referred from a source, we want to get rid of it and make sure, okay, what is the core standard um, part of the URL that you want to grab. This standardized URL does that for you. As you can see, we look at certain symbols and we want to split and just keep the core item for us. And here, let me run everything, just make sure I have them. Here, I can do a little demo. Here we have 2 URL. They both have a slight difference in their title and the URL, but they are the same source, right? So we want to make sure when we run them, in this last line, I'm asking that are they the same feed or not? So I'm making this equality. Is that correct? And it should give me the yes, they are the same. And as you can see, these two are now giving me the same. So this is one condition I'm going to use later in bottom to make sure we are not duplicating. And this is very important, especially because we're not doing a one-off web scraping. This is a scheduled, usual thing that we're gonna do, perhaps weekly, monthly, or perhaps daily. So that would be even more important the more you want to rely on your workflow. This is the logic I use essentially for the topic match, right? It's a simple logic. I have a set of keywords. I clean the text and then I search for them from the text that is provided using the keywords. Each of them, when they are found, then we return true. Now, this is something that you can make customize it. For example, perhaps you have and or condition. You want to um, separate your keywords in different buckets and you want to make sure one keyword from each bucket is there. So you can make it a little more complex, but here I have the simplest case just to have the process finished. But of course, you can have the more sophisticated NLP logic in here as well. But again, the simplest way that is most of the time perhaps is actually what you need in some, especially for initial project. That's what we have here, and I'm going to show you where we're going to use them. This is the three final data source that we need, data base, sorry, that the table that we need, and this is the format. We're going to use the SQLite tree to create the tables, and this is the just the columns and the type of data in each of them. So that would create that for us. Again, going back, I already ran it before, so you see some data inside them, but that's kind of the idea, right? So um, these are the three tables that has the main bulk of information for us. These are stuff that the news item, the web sources that are matched to our keyword has been ran in before in previous times, previous run times, and here we have the run times. We have two run before and the sources and the information that we want to grab from them. So we have the placeholder for them, right? So here, let's do a preview to see here, we're just grabbing the feed. And if we now first time we ran the feed parser, what is the information we get? One, if we just look at the first feed, right? And here we haven't done the matching with keywords yet. So this is you get different news articles from the first source that we have, and that's BBC News, and we have different items. We just look at the first few of them, right? The link published, these are the items that I'm using. This is just for demo. Next item is reading the RSS entry and putting it in a clean dictionary or format that we want to use in a next step to matching with keywords. Right? So this is that's the function that I just done a quick demo here. We are reading the summary, the title, the source name, all this information from each of these RSS feeds, putting it in a item information, and that's what we have, item one. Right? So we do a little demo here again to see that's the final format what it like in a it in itself is dictionary. You can put it in a data frame as well. We're going to use a dictionary for the next item to filter from the keyword. So this is the function that we had before, match topic. We are just use this function to loop over different items that we have and match. Okay, where do you want to actually match? We use the title and summary, right? We use those buckets of information from each RSS feed to see if the topic is matched, and it gives us a list of the matched item. So now it's converted, the dict item is converted to a set of matched list item, and that's what we have kept, right? And we can run it and see what do we have. So we have 10 items, only 7 of them are matched. You see that that's going to be the case in this test example. Next, this is a case that you only need if you want to fetch the metadata for the matched item, information such as the description um, and the content and so on and so forth, the page title, things like that. The other metadata that perhaps you haven't, it's not in the main RSS feed that you get from feed parser. You would get that using request and um, the function, the beautiful soup that we have. So this is where we put them in use. And if I ran this. And again, sometimes some RSS feeds or some resources, it blocks this. And if it blocks, then we just get a um, sorry, output here. So it's not going to give you error necessarily. So that's kind of a complementary step. Perhaps you don't need it, or let's actually see what it gives us. So if I do this and look at the feed information here is the page description, some additional information that you find in the metadata that perhaps is useful for us to. Okay, let me zoom in again. So next item, we are kind of near at the end. It's making sure we have everything in the we need to now insert them in the placeholder that we had in the database, right? We insert the source, we insert the items. That's essentially just transferring the list or dictionaries that we found, putting them, transferring them in a SQL format to SQL format, however we want to use that, to the expected tables that we have. And this is using the SQLite. So the two SQLite kind of application that we have, creating and updating the tables. That's the function that we have. I'm not gonna go over them because that's hopefully straightforward enough, but we have the function anyway. This also give you do another demo for us as well. This is the demo to make sure that the deduplication that we've done is actually correct, right? So if we ran this first feed and we ran it twice, so I've gave the first feed 2 times to the update source. And this update source, so the logic that is also there is the second part that you can make sure duplication is not happening, and that is in the logic of the SQL that is happening here, right? So this logic makes sure that if we run this same feed twice, let's see which if the second time it is inserted as well, right? So if we do that, wait a little bit. Interestingly, the reason it shows us that none of them is inserted because I just actually ran this just before for a demo, and both of them is actually were already inserted in a database. So that's why we should be expected this to be 0 if you already inserted this feed information in your database. So that's just a small demo to also highlight that we have at least 2 places here to make sure duplication are not happening in the standardizing the URL and also in inserting in a database. So that was the demo, but now let's run it for the whole information for the whole RSS feed that we had for overall and putting them in. So we ran it, we found this many matched information, and again, because I already inserted that information, we're not getting a new duplication, which is that's what you expect. But again, if that's the first time you add it, you expect that all these 62 items to be inserted now. And lastly, this gives us that HTML format that we want. I there are 2 pieces of information that we had in that HTML format. If I get back to it, which is this is the latest item, and I just have the dashboard for the number of times we have this mentioned. So if we go back, that essentially gives us the information, the latest information, and that's the timeline information that we have. Essentially, I just need to um, group, find the size of the time that we have something matched in the timeline df. That's kind of everything that we have from our item data source. And over different week, I look at the size, and you see we have some pattern here. Interestingly, now that I ran it in a different form, in a new item. And lastly, we are creating that HTML file. So that HTML format, again, I have it here. That is some header information. The body is just that 2 item that it there was, the latest item, and also plot that we had. So if we run this, that should give us again the updated information for the HTML file that we can see if the plot is now updated, and also the resource should be updated. So this is the three information, the output that I already showed you. That is the new item in a CSV. That is the final resource item that is matched. And again, perhaps for delivery of the report, we need something like this. So as you can see now, updated it. We have new item and the plot is now updated as well. Hopefully this is useful for you. We have a workflow for scraping that makes sure duplication doesn't happening. We use SQLite, Python scraping, and RSS feed. See you in next video.